Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present about wired and wireless networks and devices. This slide is prepared by Noaimah Salihah binti Syahri, Nur Afifah binti Azlin, Siti Nur Zahira binti Nur Azam, and Aina Najwa binti Muhammad Nur Shah. What is communications? Communications is a process in which two or more computers or devices transfer data, instructions, and information. Some communications involve cables and wires, while others are connected wirelessly through the air. So, how can we achieve a successful communications? First, we need a sending device. A sending device is a device that initiates on instruction to transmit data, instructions, or information. Next, we need a communications device. A communication device is a device that connects the sending device to transmission data and later to the receiving device. Third, we need a transmission device, or it is also known as communication channel, which is a channel where the data, instructions, and information travel, and it can be wired or wireless. Lastly, we need a receiving device. A receiving device is a device that accepts transmission of data, instructions, or information. Moving on, we are going to talk about networks. So, what is a network? A network is a collection of computers and devices that are connected via communication devices and transmission media. Network can be either internal to an organization or span the world by connecting to the internet. Many home and business users create a network to facilitate communications, share hardware, share data and information, share software, and also to transfer funds. Instead of using internet for investing in and administering an internet network, some companies hire a value-added network (VAN) provider for network function. So what is a value-added network or VAN? It is a third-party business that provides networking service such as EDI services, secure data, and information transfer, storage, or email. Some VANs charge an annual or monthly fee, for example, PayPal, while others are charged by service use. There are various types of networks that are usually classified as local area network, metropolitan area network, wide area network, or personal area network. The main difference is the area of coverage. First, we're going to talk about local area network, or LAN. LAN is a network that connects computers and devices in a limited area, for example at home, school, and also office building. So LAN also has a wireless type. So this which is called as WLAN. So WLAN is a LAN that uses no physical wires, which means it is wirelessly. Next is Personal Area Network, or PAN. PAN is a network that connects computers and devices in an individual's workspace using wired and wireless technology. Next is Wide Area Network, or WAN. WAN is a network that covers a large geographic area using a variety of wired and wireless transmission media. Lastly is the Metropolitan Area Network, or MAN, which is a high-speed network that connects local area networks in metropolitan area such as city, and also handles the bulk communication activity across the region. Network architectures. What is network architectures? Network architectures is the configuration of computers, devices, and media on a network. There are two examples of network architectures, which are client or server or peer-to-peer. What is client or server? On a client or server network, one or more computers act as a server, and the other computers on the network request services from the server. A server, or a host computer, controls access to the hardware, software, and other resources, and provides a centralized storage area for programs, data, and information. A client are other computers and mobile devices on a network that rely on server for its resources. Next is peer-to-peer. Peer-to-peer is a simple, inexpensive network architecture that connects fewer than 10 computers. Each computer or mobile devices, which is called as peer, has equal responsibilities and capabilities, sharing hardware, data, or information with other computers and mobile devices. This network allows users to share resources and files located on their computers and to access shared resources found on other computers in the network.
Next, network communication standards and protocols. Next, Wi-Fi. Devices that have the appropriate wireless capability can communicate via radio waves with other devices using Wi-Fi. Sometimes it is referred to as wireless Ethernet because it uses techniques similar to the Ethernet standard. In open or outdoor areas free from interference, the computers or devices should be within 300 feet of a wireless access point or hotspot. Meanwhile, in closed areas, the wireless network range is about 100 feet. To obtain communications at the maximum distances, you may need to install extra hardware to extend or strengthen a wireless signal. Move on to the LTE. It stands for Long-Term Evolution. LTE is a network standard that defines how high-speed cellular transmission use broadcast radio to transmit data for mobile communications. LTE has the potential of 100 Mbps downstream rate, receiving data, and 30 Mbps upstream rate, sending data. So, what is standards and protocols? For the different devices on various types of networks to be able to communicate, the network must use similar techniques of moving data through the network from one application to another. For that reason, standard and protocol makes network works together. Standards. A network standard defines guidelines that specify the way computers access the medium to which they are connected, the types of medium used, and also the speeds used on different types of networks. Meanwhile, a protocol is a standard that outlines characteristics of how two devices communicate on a network. Specifically, a protocol may define data format, coding schemes, error handling, and also the sequence in which data transfers over a network. When a computer sends data over the internet, the data is divided into packets. Each packet contains the data as well as the recipient, the origin, and also the sequence information used to reassemble the data at the destination. Each packet travels along the fastest individual available path to the recipient's computer or mobile device via routers. This technique of breaking a message into individual packets, sending the packets along the best route available, and then reassembling the data is called packet switching. Bluetooth. Bluetooth uses short-range radio waves to transmit data. To communicate with each other, Bluetooth devices often must be within about 33 feet, but can be extended to about 325 feet with additional equipment. For computers and devices that are not Bluetooth enabled, you can purchase a Bluetooth wireless port adapter that will convert an existing USB port into a Bluetooth port. When connecting two devices using Bluetooth, the originating device sends a code to the connecting device. The codes must match to establish the connection. Devices that share a Bluetooth connection are said to be paired. Next, UWB. UWB stands for Ultra Wideband. It uses short-range radio waves to communicate at high speeds with each other. UWB can transmit signals through doors and other obstacles. Because of its high transfer rates, UWB is best suited for transmission of large files such as video, graphics, and audio. Ethernet. Ethernet currently is the most popular network standard for LANs, which stands for Local Area Network. It specifies no central computer or device on the network should control when data can be transmitted. Ethernet networks often use cables to transmit data. Other than that, it is also relatively inexpensive and also easy to install and maintain, making it the most popular network standard for lines nowadays. Data transfer rate from 10 megabits per second to 100 gigabits per second. Token ring. It specifies that computers and devices on the network share or pass a special signal called a token. A token is a special series of bits that functions like a ticket. The device with the token can transmit data over the network. However, only one token exists per network. This ensures that only one computer transmits data at a time. Although token ring is not as widely used today, many networks use the concept of a token. Data transfer rate on a token ring network ranges from 4 megabits per second to 1 gigabits per second. TCP or IP. TCP or IP are shorts for a Transmission Control Protocol or Internet Protocol. It defines how messages or data are routed from one end of a network to other, ensuring the data arrives correctly. TCP or IP describes rules for dividing messages into small pieces called packets. IRDA. IRDA or Infrared Data Association Standard transmit data wirelessly to each other via infrared light waves. Infrared requires line of sight transmission. That is, the sending device and the receiving device must be in line with each other so that nothing obstructs the path of the infrared light wave. Because Bluetooth and UWB do not require line of sight transmission, these technologies are more widespread than IRDA. RFID. RFID or radio frequency identification use radio signals to communicate with a tag placed in or attached to an object, an animal, or a person. The tag, called a transponder, consists of an antenna and a memory chip that contains the information to be transmitted via radio waves. Through an antenna, an RFID reader, also called a transceiver, reads the radio signals and transfers the information to computer or computing device. And the last one is NFC. It stands for Near Field Communications. It uses close-range radio signals to communicate between two devices or objects equipped with NFC technology. NFC tag is a chip that can store small amounts of data. For successful communications, the device or objects touch or are placed within an inch or two of each other. As you can see in the picture, the laptop is equipped with an NFC tag. Meanwhile, the device or phone must be equipped with NFC technology so that these two devices can communicate, such as transferring files and so on.
Next, we are going to talk about communication lines. Dedicated lines. A dedicated line is a type of always-on physical connection that is established between two communication devices. It is often used by businesses to connect geographically distant offices. It can either be analog or digital. The digital dedicated lines include cable, DXL, ISDN, and etc. So the table 10.2 shows the speeds of various dedicated digital lines. For example, like the type of line is cable and the transfer rate is 250 kbps to 52 mbps. Moving on, we are going to talk about digital dedicated lines. So the first one is cable. The cable television or CATV networks provide high-speed internet connections, which is called cable internet service. The CATV enters a building through a single line called coaxial cable, which connects to a modem which typically attached to your computer via an Ethernet cable. So this type of digital dedicated line usually used by home and small business users to cable internet service. Next is the digital subscriber line or DXL. DSL transmit on existing standard copper phone ring. Some DSL installations include a diatone which provides users with both voice and data communications. DSL installations often require filters to be installed in order to reduce noise interference during communication. Next is the Integrated Services Digital Network or ISDN. ISDN is a set of standards for digital transmission of data over standard copper phone lines. With ISDN, the same phone line can only carry one line. A single same phone line that can only carry one line can now carry 3 or more signals through the same line. This is called multiplexing. Moving on, next is fiber to the premises or FTTP. FTTP uses fiber optic cable to provide extremely high-speed internet to users' physical permanent location. Through FTTP service, an optical terminal at your location receive the signals and transfer them to a router connected to computer. Next is T-carrier. T-carrier line is any several types of long-distance digital phone lines that carry multiple signals over a single communication line. This line provides a very fast data transfer rates. Only medium to large company can afford T-carrier lines due to its high price. And lastly is the asynchronous transfer mode or ATM. ATM is a service that carries voice, data, videos, and media at very high-speed networks with large amounts of traffic use ATM.
A communication device is any type of hardware capable of transmitting data, instructions, and information between a sending device and a receiving device. At the sending end, a communication device sends the data from the sending device to transmission media, while at the receiving end, a communications device receives the signals from the transmission end. Next is digital modems. A broadband modem, also called as a digital modem, is a communications device that sends and receives data and information to and from a digital line. Three types of broadband modems are cable modems, DSL modems, and ISDN modems. First is the cable modem. A cable modem is a broadband modem that sends and receives digital data over the CATV network. To access the internet using the CATV service, the CATV provider installs a splitter inside your house. From the splitter, one part of the cable runs to your televisions and the other part connects to the cable modem. Many CATV providers include a cable modem as part of the installation. Some offer a rental plan and others require that you purchase one separately. Next is the DSL modem. A DSL modem is a broadband modem that sends digital data and information from a computer to a DSL line and receives digital data and information from a DSL line. Similarly, an ISDN modem is a broadband modem that sends digital data and information from a computer to an ISDN line and receives digital data and information from an ISDN line. Wireless modems, which have an external or built-in antenna, are available as USB adapters and other devices. Some smartphones also can function as a wireless modem called a mobile hotspot when tethered to a personal computer or mobile devices. Wireless access points, WAP, is a central communication devices that allows computer and devices to transfer data wirelessly among themselves or to a wired network using wireless technologies such as Wi-Fi. For the best signal, some manufacturers suggest positioning the wireless access point at the highest possible location and using a device to strengthen your wireless signal. Next is the routers. A router is a communication device that connects multiple computer or other routers together and transmit data to its correct destination on a network. If the network has a separate router, it connects to the router via a cable. Similarly, if the network has a separate wireless access point, it connects to the router via a cable. Network cards. The network cards is sometimes called a network interface card, NIC. It is a communication device that enables a computer or device that does not have a built-in networking capability to access a network. The network cards coordinate the transmission and receipt of data, instructions, and information to and from the computer or device containing the network card. It is available in a variety of styles. A network card for a desktop is an adapter card that has a port to which a cable connects. For mobile computers and devices, it is in the form of a USB adapters or other device. Hubs and switches. A hub and switch is a device that provides a central point for cables in a network. Largest networks typically use a hub, while smaller networks use a switch. Some hubs and switches include routers. The hub or switch receives data from many directions and then forwards it to one or more directions. Continuing to the home networks, many home users connect multiple computers and devices together in a home network. Vendors typically offer home networking packages that include all the necessary hardware and software to network your home using wired or wireless technique. Extensive knowledge of networks to set up a home network is no longer needed. For example, desktop operating systems often enable you to connect all computers in your house to a home network easily. To detect an intruder accessing your wireless home network, you should sign in to the administrative interface, count the number of connected devices, and secure the network by changing the default network name and password. Mini feature 10.3 Planning and designing your home network. Home network enables us to use a common internet connection among many computers and mobile devices. Other uses include connecting entertainment devices such as DVRs and TVs to the internet and establishing a connection between devices to play multiplayer games. Before purchasing hardware or contracting a network expert to set up the network, consider how the network will be used and by whom, and ask yourself the following question. First, what devices will connect to the network? The number of devices as well as the operating system or platform on which the devices operate, which will determine the speed and strength needed to run your wireless network. Secondly, how large of a range do you need, and where will most of the use take place? Because if you have a small apartment, your needs will differ from those with a large home. The third question is, how many users typically will be using the network? How will they use it, and for what purposes? The number of users affects the capabilities of the networks and determines whether you need to define permissions for certain users or devices. Lastly, how secure do you need your network? Hiding the network name, requiring passwords, or having a user with network administration capabilities can help ensure your network is safe from unauthorized use. The following is the hardware needed for a wireless internet connected home network. The first is router. The router establishes the connection between the internet and all devices on the home network. Next is wireless access point, which is often included as part of the router in order to connect wireless devices. The third one is the modem, such as a cable or DSL modem that connects to an ISP and establishes the internet connection for the network. Lastly is the computers and devices such as desktops, laptops, tablets, smartphones, televisions, cable set-top box, or a voice-over IP phone that you connect to the home network.
Next, we will continue on transmission media. Transmission media consists of materials or substances capable of carrying one or more communication signals. When you send data from a computer or mobile device, the signal that carries the data may travel over various transmission media. Transmission media, including both physical and wireless, are used to complete a data request over the internet. Although many media and devices are involved, the entire communications process could take less than 1 second. Broadband media transmit multiple signals simultaneously. Bandwidth is the amount of data, instructions, and information that can travel over the transmission media. The higher the bandwidth, the more data transmitted. For transmission of text only, a lower bandwidth is acceptable, but for transmission of music, graphics, photos, visual reality image, or 3D games, you need a higher bandwidth. When the bandwidth is too low for the application, you will notice a considerable slowdown in system performance. Latency in communications is the time it takes a signal to travel from one location to another on a network. Several factors that negatively can affect latency include the distance between the 2 points, the types of transmission media, and the number of nodes through which the data must travel over the network. For the best performance, bandwidth should be high and latency low. There are two types of transmission media, which are physical transmission media and wireless transmission media. Physical transmission media use wire, cable, and other tangible materials to send communication signals. These wires and cables typically are used underground or within or between buildings. There are three physical transmission media. The first one is twisted pair cable, one of the more widely used transmission media for network cabling and landline phone system is twisted pair cable. Twisted pair cable consists of one or more twisted pair wires bundled together. Each twisted pair wire consists of two separate insulated copper wires that are twisted together. The wires are twisted together to reduce noise, which is an electrical disturbance that can degrade communications. The second physical transmission media is coaxial cable. Coaxial cable, often referred to as coax, consists of a single copper wire surrounded by at least three layers. The first one, an insulating material, the second one, a woven or braided metal, and the third one, a plastic outer coating. CATV refers to cable television. CATV network wiring often uses coaxial cable because it can be cabled over longer distance than twisted pair cable. Most of today's computer networks, however, do not use coaxial cable because other transmission media, such as fiber optic cable, transmit signals at faster rates. The third physical transmission media is fiber optic cable. The core of a fiber optic cable consists of dozens or hundreds of thin strands of glass or plastic that use light to transmit signals. Each strand called an optical fiber. An optical fiber is as thin as a human hair. Inside the fiber optic cable, an insulating glass cladding and a protective coating surround each optical fiber. Fiber optic cables have the following advantages over cables that use wires, such as twisted pair and coaxial cables. Capability of carrying significantly more signals than wire cables, faster data transmission, less susceptible to noise from other devices such as a copy machine, better security for signals during transmission because they are less susceptible to noise, and lastly, smaller size, which is much thinner and lighter weight. The disadvantages of fiber optic cable are it costs more than twisted pair or coaxial cable and can be difficult to install and modify. Despite these limitations, many phone companies replace original analog phone lines with fiber optic cables, enabling them to offer fiber optic internet access to home and business users. The next type of transmission media is wireless transmission media. Wireless transmission media send communication signal through the air or space. Many users choose for wireless transmission media because it is more convenient than installing cables. In addition to convenience, business use wireless transmission media in locations where it is impossible to install cables. Types of wireless transmission media used in communications include infrared, broadcast radio, cellular radio, microwave, and communication satellites. The first wireless transmission media is infrared. Infrared is wireless transmission medium that sends signals using infrared light wave. Mobile computers and devices such as a mouse, printer, and smartphone may have an infrared data association port that enables the transfer of data from one device to another using infrared light wave. Next wireless transmission media is broadcast radio. Broadcast radio is a wireless transmission medium that distributes radio signals through the air over long distance such as between cities, regions, and countries, and short distance such as within an office or home. For radio transmission, we need a transmitter to send the broadcast radio to signal and a receiver to accept it. To receive the broadcast radio signal, the receiver has an antenna that is located in the range of the signal. Some networks use a transceiver which both sends and receives signals from wireless devices. Broadcast radio is slower and more susceptible to noise than physical transmission media, but it provides flexibility and portability. Bluetooth, UWB, and Wi-Fi communication technologies use broadcast radio signals. Bluetooth and UWB are alternative to infrared communication, with the latter designed for high bandwidth transmissions. Cellular radio is one of the wireless transmission media. Cellular radio is a form of broadcast radio that is in wide use for mobile communications, specifically wireless modems and mobile phones. Mobile phones use high-frequency radio wave to transmit voice and digital data messages. Because only a limited number of radio frequencies exist, mobile service providers reuse frequency so that they can accommodate the large number of users. Some users install an amplifier or booster to improve the signal strength. Examples for several categories of cellular radio transmissions are 1G, 2G, 3G, 4G, and 5G. G for each cellular radio transmission stands for generation. For example, 1G stands for first generation, and so on for 2G, 3G, 4G, and 5G. Next wireless transmission media is microwave. Microwave are radio waves that provide a high-speed signal transmission. Microwave transmission, often called fixed wireless, involve sending signals from one microwave station to another. A microwave station is an earth-based reflective dish that contains the antenna, transceivers, and other equipment necessary for microwave communications. As with infrared, microwave use line-of-sight transmission. To avoid possible obstructions, such as buildings or mountains, microwave stations often sit on the top of buildings, towers, or mountains. Microwave transmission typically is used in environments where installing physical transmission media is difficult or impossible, and where line-of-sight transmission is available. For example, microwave transmission is used in wide open areas such as desert or lakes, between buildings, in a closed geographic area, or to communicate with a satellite. We move on to communication satellite. A communication satellite is a space station that receives microwave signals from an Earth-based station, amplifies the signals and broadcasts the signals back over a wide area to any number of Earth-based stations. These Earth-based stations often are microwave stations. Other devices such as microphones and GPS receivers also can function as Earth-based stations. Transmission from an Earth-based station to a satellite is an uplink. Transmission from a satellite to an Earth-based station is a downlink. With satellite internet connections, however, uplink transmission usually are slower than downlink transmission. This difference in speed usually is acceptable to most internet satellite users because they download much more data than they upload. Although a satellite internet connection is more expensive than cable internet or DSL connections, sometimes it is the only high-speed internet option in remote areas. The last wireless transmission media is GPS. GPS stands for Global Positioning System. It's a navigation system that consists of one or more Earth-based receivers that accept and analyze signals sent by satellites in order to determine the receiver's geographic location. Many mobile devices such as smartphones have GPS capability built into the device or as an add-on feature. Some users carry a handheld GPS receiver, others mount a receiver to an object such as an automobile, a boat, airplane, farm and construction equipment, or a computer or mobile device. A GPS receiver is a handheld mountable or embedded device that contains an antenna or radio receiver and a processor. Many include a screen display that shows an individual's location on a map. This is how a GPS works. Step 1. GPS satellites orbit Earth. Every thousandth of a second, each satellite sends a signal that indicates its current position to a GPS receiver. Step 2. A GPS receiver, such as in a car, a smartphone, a wearable device, and a handheld device or a dog collar, determines its location on Earth by analyzing at least 3 separate satellite signals from the 24 satellites in orbit.